Good afternoon, everybody. This is a short presentation on the generic Gen 3 pressurized water reactor that WSC provides for training purposes and for R&D purposes and beyond. Today, myself, Usama Ashi, and Mr. Majid Mirsha, we will be providing this presentation. Between the two of us, we've had over 60 years of working on simulators worldwide, and we're proud of this product to show you what we have. Short description of WSC: we are a small company, about 85 people. 50 of us are in Frederick, Maryland, and the rest are in various locations in the world. We have delivered over 250 simulators worldwide, and we continue to spend 20% of our profit in R&D. Our highest revenue is in nuclear engineering and nuclear simulators, although we have done combined cycles, thermal plants, and the use of simulation in engineering design. We also do some work with the Navy for nuclear Navy and some work in chemical and pipelines. Also, what's missing here is grid simulators. Last couple of years, we have done few grid simulators. As I said, full scope nuclear simulators has been our business. The picture on the right bottom is one of the nuclear simulators we delivered in China, which is also a Gen 3 nuclear power plant. And as you note, the DCSs are, most of the control is done through distributed control systems. Our business also includes the use of simulation in design. Companies such as GEH and others have used the simulator in system analysis, human factors, INC, DCS, VMV, and plant optimization and procedure development. The history of the Gen 3 PWR, we developed it for INIC, NOAA, in United Arab Emirates initially, with a multi-million-dollar contract, and this was due to them needing a simulator before their custom simulator, which was built by us also, was delivered. So we had to convert a traditional nuclear power plant control room into a DCS type control room. This was replaced by the actual nuclear simulator that you see here, and currently they have 4 of these nuclear simulators due to the amount of operators they are training. For Baraka nuclear power plant, there's also multiple simulation platforms. There are limited scope simulators, which you see on the top left. There are engineering simulators that are called part task simulators that allow for system understanding and also debugging of issues in the plant. We also maintain a platform in WSC for them where we do upgrades and continue upgrading the simulator to the same state as the plants. One of their most problematic issues is that they had started the nuclear program and required hundreds of employees to be trained on nuclear technology. And it's not only operation, but engineering, even management and maintenance, and etc. So that required ways of educating, recruiting, and getting the next generation of engineers into the nuclear industry in United Arab Emirates. The capabilities of this simulator is that it is a modern Gen 3 control room. It provides a very good understanding of the nuclear systems and fundamentals, and it can take you to any component in the nuclear power plant and provides the ability to operate, control the plant, and look at transients, understand fundamentals of nuclear power, and introduce nuclear safety culture in the plant. What differentiates our generic PWR from others is that the controls of this generic PWR is all done through graphics rather than panels. What we have found through providing panel simulators is that students or operators have a hard time finding equipment in a panel. It takes years to understand a panel control room, whereas in the generic PWR it's very easy to access different systems, different controls within any system in the plant. The GPWR includes about 70 to 80 graphic screens that allow you to operate the system. It includes an alarm system, an event system, trending, a full instructor station, and it can operate in a classroom as well as in a single platform or a web-based delivery. Some of the plant overview screens, this is the top screen with the full view of the plant, as well as the screen with the menu taking you to any system in the plant. The simulator is able to do normal operation from shutdown to 100% power and back to shutdown, but it also allows for malfunctions to be inserted and changes to the plant that are needed for various R&D or other applications. Some of the HMI screens, this is rod control, in-core exit temperatures, main generator, and turbine generator vibration monitoring. It has alarming system, an event system, and a trending system. And we added certain quasi 3D graphics to provide the user a view of void, pressure, temperature of the reactor, as well as the flux in the reactor through the 3D model that is provided. This model is based on Nestle code, and it's a 3D full scope neutronic model. The pop-ups are very simple to understand. There's, you click on a valve, it's open and close. You click on a controller and you'll see the PID controller with its parameters, trended, etc. Also, the simulator comes with a full instructor station, allows for use of the simulator in training, and allows for insertion of malfunctions, snapping initial conditions, etc. This is some view of how this simulator was applied in a classroom. The top right is something we delivered through the IAEA, International Atomic Energy, a few years ago to countries that are starting to think of nuclear power as a source of energy in their country. We've also delivered the simulator on panels. These are called 3 key touch panels. We were on the cover of Nuclear News maybe a couple of years ago. Mr. Mirsha was one of the people in the picture delivering this simulator to a college. We've delivered these touch screens on traditional control rooms, such as this one, which is Palo Verde. In addition to that, we recently have been delivering this on cloud computers, allowing students to access the simulator through the internet. And the color scheme that you see with yellow and green and red just indicates that different lessons can be run by different people. Access to these lessons is independent of what lesson you are taking. Where the simulator is sitting today, some of the organizations that have it and use it, whether it's on the web or local computers or a classroom environment, these have been various ways of delivery. And some of them have been also for R&D purpose, where the simulator is being used for certain research and development. What we deliver with the simulator is this 3 Master simulation environment, which includes all the modeling tools, a two-phase flow-based network, and electrical network, a logic control, as well as the DCS HMI and Instructor station. It includes the Nestle code for the neutronic reactor physics, and it's available in various versions. The GPWR has a British units version, an SI unit version, and optionally we can provide it with RELAP 5 as the thermohydraulic code. And with what we call the intelligent tutoring system, which we will demo later in this presentation. So the simulator can be provided in a single machine for use in R&D or control, or a control room setup such as this one, or a classroom setup, or through 3-key touch units, or a combination of both. And this picture comes from Sharjah University in the UAE, where they have a classroom and the 3-key touch units. 3-key touch units are usually used by the instructors to provide feedback to the students. The latest delivery through the web allows you to have access to it from anywhere in the world, including functionality such as trending and control. So you could actually do a startup of this plant through the web and see alarms and listen to the script of the lesson through the intelligent tutoring system. The intelligent tutoring system was developed a few years ago under an EPRI contract and has been used recently in our web applications to deliver lessons through the web that are scripted, allowing someone to come into the web and follow instructions for the simulator. With this, I'm going to turn it to Majid, and he will do a few demos for us. Basically, he will go through the GPWR functionality and take you to the GPWR on the cloud and show the ITS capabilities.
Greetings. To start the GPWR, I basically log in. I can log in as a developer where you have access to models to make changes to the GPWR models, or you can sign in as an instructor, which you can control the simulator and or operator students, and so on. And if I select the instructor, the simulator is fully up and ready to be used. I go ahead and run. If I bring another, if I sign in as a client or as a student, can connect to this simulator. For example, if I select this, I bring another HMI or that I can control the simulator from it. You can open up as many of these for a teamwork or in a classroom environment. Now, if I choose the initial conditions of the plan, there are many initial conditions, or we call it ICs, are provided for different core lives, but you can snap any initial condition that you like for your running your own scenarios. I reset to a initial condition which has no alarms. No alarm sounds basically, and I'll choose a overview, put the simulator into run. The middle is the main HMI page to operate, control the plant. The important parameters information are here. So you can see the status of the plant, and reactor and turbine are online or not. And here you can see that if you are running scenarios or you're having malfunctions, leaks or component malfunctions. And here there is a facility basically to the right is simulator control and facility for instructors and the users. And on the bottom there is a home, a menu, a list of HMIs, and there is a alarms, events, and trends, and 2D primary system presentation, which I'm going to show some of these to you. Basically from the main HMI, this is a 1400 megawatt plant. This is the reactor, 4 cooling pumps, 2 steam generators, and the pressurizer, and accumulators for providing for safety system, for loss of coolant, providing the water. And then in the left side you have the primary system supports, like chemical volume control system, RHR, and safety injection. And in the right you basically have the turbine island with the turbines and electrical generator. And some of there are important HMIs are also clickable here, or they are active. For example, you can click on here and you can see that exit temperatures of the core and reactor core level indications. So clicking home, you will see basically all the HMI pages are organized by their systems or functions. Like these are the primary systems, controls, and statuses, balance of plant system, turbine generator, safety, electrical, cooling water, and ventilation. So from here, you can click on diagrams to HMIs and operate. And for example, the flux distribution, What you're seeing here, basically, we're using Nestle core modeling. So every of these nodes are calculated in the core model. That's the flux shape, is the middle of life core. You have the power density indication or fuel temperature, moderator, moderator density, and then a rodded fraction, meaning all the rods are out of the core. On the controls, I like to show the reactor rod drive system or reactor rod control, and right now we are in automatic. If I select manual group and group 3, I can insert the rods. You will see the rods are stepping in. And if I trip the reactor, you will see the power indications, and you're also going to see the rods getting inserted in the core. So if you look at the trends, for example, you will see basically the trends indicating that the reactor has tripped. Resetting to the 100% again. Show you the backtrack. Basically, the simulator is snapping automatically initial conditions based on user specified interval. So if you're running a long scenario and you want to go back in time to show the students or observe yourself the situation, you may go back to in time. We have a very good 2D representation of primary system, a good visualization of the primary system. Let's insert a malfunction loss of coolant. We go into the malfunction list and selecting primary system malfunctions. If I select the cold-lead break and I put let's say a delay time of 5 seconds, ramp time of a minute, and the final value being 50% break, you will see that it's counting down by 5 seconds, and then the malfunction get inserted. The malfunction is here in the core leg. You will see that the pressure drops in the primary system. You will see the temperatures are changing in the primary system accordingly, and the void. Another functions that I wanted to show you, the user can make a list of parameters that they are interested to look at for different transients, and we call them monitor parameters. So if I select a few of these, for example, I can trend them. We call this a pop-up trend. You can also trend them a split, or uh, you can dump the values to a file for analysis, or to save the files, or so on. So there are so many functions of the trending functions. Reset the simulator again. Uh, and this time we like to discuss scenarios. There are scenarios that they've already set up and is provided with the GPWR, but you can basically make new ones or capture the scenario as you're running a scenario, and you can rerun that scenario later for you. If I select the mainstream line break, rupture is one scenario we set up, and I run that. Uh, if I run that, basically shows that one scenario is inserted. There is a malfunction that is 20 seconds on it. I can execute it. So the malfunction basically this was a initial condition that had this alarm sound in it. Anyhow, the malfunction got activated, and we have a main streamline break. Another another function that I'd like to show you is selecting malfunction mode. You basically see all the malfunctions that they are available on the HMIs. For example, here you can have feed water header break, right? You can insert the malfunction from the PNID. And then you have malfunction component malfunctions for valves and pumps and transmitters and so on. So if I select this transmitter, which is a steam generator narrow range level indication, if I select one of the transmitters, I can, for example, introduce some noise into this transmitter. And you basically see noise indication on it. Shows in here, shows also on the transmitter itself. And feed water level control is trying to maintain the steam generator level. You see, has basically this noise has affected the controller itself. Other capability that simulator has, you may run the simulator in a slow time, normal, or fast, and you can also uh, increase the xenon and decay heat by 1,000 times. Run it fast, and you can silence the alarm. There are many features that here that I cannot cover due to the time, limited time. So if you click on help, you basically open up the list of documentation that is available. Instructor station user guide describing all the functionalities of the for instructor, or how to control the simulator and use the simulator. Then there is a training guide for the GPWR itself, and training presentation. There are a bunch of exercises also, and then there is a start and shutdown procedure for the plant, and there is a ITS Intelligent Tutoring System guide, which ITS gonna be described later. And then we have the Transience test report, which is basically It has all the ANS 3.5 standard transients, and it it shows that basically the simulator meets that standard. If I click on the instructor guide, you basically see the user guide and how to use the simulator. Running scenarios, and inserting malfunctions, how to use the trends, and so on. So if you go in the middle, you basically have everything that you need to control the simulator. Now showing the GPWR on the clouds, hosted by WSC. This is like for Bismarck State College. The students can sign in, they get into LMS or Learning Management System that WSC has set up for the school. GPWR is one of the simulators that they are using for teaching. There are other simulators here. If you are interested, we can discuss that at a later time. Another school is a slightly different login. You basically get to this window which you can select the lesson or module that is set up for students to practice, and you enter. We use ITS window where you're seeing here to give some instructions to the students who are coming to the web. Of course, this also can be used in the local, but so I will run the simulator now, and lesson starts.
Using the critical parameter status bar, verify the current plant power.
I click on Advise.
The unit is operating at 48% power with the steam generator water levels at a normal level. Used from the main feedwater overview HMI, determine the status of the main feedwater pumps. As shown on the HMI, the A main feedwater pump is operating in auto, controlling steam generator water levels, and the B main feedwater pump is warming at 1125 RPM.
I mute the sound. You see that basically the advise will bring the HMI that the students is supposed to look at, and also highlights the icon or item that they're supposed to look at. In this case, they're supposed to look at this controller for a steam generator level controller. So that's basically wanted to show you that. And then another beauty of these clouds, you can, if you have more monitors, you can open more windows. So you have, like right now I have this and that which are connected, is running the same clock, and you can separate them and put them in another window. So like right here, I can basically place that in another window and use it. Thank you. This is the end of my presentation.
Thank you, Majid, for the demonstrations. And one of the questions we always get is, how did GPWR get funded? And what I can say is that a lot of them were through educational grants, although we've had direct funding from different companies and through the IAEA to international. The web-based simulation has become very affordable, and we would like to discuss that with you on a one-to-one basis. What drives the cost on the cloud system is the capacity of computers we keep to run the simulator in parallel. for multiple students. And we would discuss that one-to-one with you as your interest, based on your interest. This is a sample of a website that the students would access and how they launch the simulator. The simulator can be used in training, engineering, education, PR, and it has been used in all those areas. It's convenient, it's available, it's always there, and with minimal upkeep once you have it up and running. WSC has developed other simulators such as this one, which is BWR, with various systems and graphics and very similar to the PWR, and provides a neutronic view of the reactor physics as well as the thermohydraulics. We also have developed VVR, which is a Russian design for various countries that are building VVR power plants. This is a view of the instructor station for the VVR. We thank you for attending this meeting, this webinar, and if you have any questions of me or Majid, you may email us at these numbers, these email addresses, and you may call us at the numbers provided. Thank you. Have a good afternoon.